Hi, good day. For this tutorial, we'll be learning how to use the basics of Autodesk Inventor Cam. We're going to work with a small block and drill some holes, do some of the operations on it, like facing, uh, drilling, contouring, and so on. So let's start with it. Before we start making our model, before we start working on the cam, we need to firstly make the model. And the model is 50 by 60, and we have holes of 10 of holes of 8 mm inside it. So let's go straight to our inventor. So this has already been done. I'm going to create a new file. So I'm going to work with So click on new and create. So the dimension is 60 by 50. 60 by 50. Okay. I'm going to create holes inside it. So the hole is 8 mm, 8, 8, and this is also 8. Okay, so this should be 10, this should be 10, and so this should be 10 too. Okay, so 10, so this should be 10. Likewise, this should also be 10. So let's check if we have all the dimension. So 50 by 60, 8 mm, and 10. So we're going to extrude to a distance of 10 mm. So we have everything ready. So finish sketch. I'm going to extrude it to 10. Okay. Then decide the material. Just okay. Material is mine still from the question. So still mine. So I'm going to block machine. Okay. Now, if you have Autodesk Inventor installed on your system, so if you click on this place, you're going to see the Inventor cam. So the first thing we want to do is to create our setup. So when we're creating our setup, we need to define our geometry. Now, looking at in cam, cam always works in such a way that the vertical cut is taken by Z. So, and look at where our Z is facing. So let's firstly select the type of operation we want to work with. So we want to work with milling operation. So where do we want to, how do we want to do our orientation? I'll come to select the Z axis. So I'm going to select Z axis and I'll select this line. So you can see the Z is facing up like that. So it's asking for X axis. So you can tell it, okay, the X axis. So okay, the Z. So my Z axis will be here. So and X axis, you can see the X axis will be here. So it's still aligned with whatever I want. So I will now come to this place and what select points. So I'm going to select this point. So is going to come here as my select point. So, and another thing I need to set is my stock. The stock is just the size of the workpiece you're given, the size of the raw material you're given. So looking at this, they said the my steel material is 54 by 64 by 12 mm. So I'm going to come here. Look at what we have here under our stock size. We have 62 by 52 and 12. So I have to change this. I have to what? Work on my offset. Tell it, okay, increase the offset and the side offset and increase the top offset. Now let me look at it now. You can see I have 2 mm here. I also have 2 mm here. I have 2 mm at the top, which works with what we're given. So this is exactly the size of what we were given uh as our dimension. So click OK. So we're done with that. So then the next thing we're working with is going to be the facing operation. The next thing we'll be working with will be the facing operation. Now, after we click on our facing operation, so click on facing and the tool. Now we need to select the type of tool that we want to work with. And for us to do our facing, we either use an end mill. Yes, we use an end mill for it. So click on by type. The flat mill, you can select the flat mill or the face mill. Yes, or we can choose a face mill. Is there anything? Yes, face mill. Okay, face mill. So you can choose any of it. We decide to select this, and this will not produce a very good finishing, since the diameter, the one we have inside the library, the diameter is 50 mm, and we know the size of our workpiece around that too. So it's better for us to go with our flat end mill. Go with our flat end mill. So let's just select 10 mm. Select 10 mm so that the cut will be taken bit by bit. So I'll select. I'm going to select. So now the spindle speed, based on dimension we're given here, they said the spindle speed is 1000, the feed rate is 20 mm, the depth of cut is 1 mm. So the spindle speed is 1000 and 20 for the feed rate, cutting feed rate is 20. So now we select where we want to work with, where we want to face. So I want to face this place, so I'm going to select it. So the tracked height, these are just the parameters that determine how much our tool is going to move after each of the operations or at the end of every operations. So now for this tool, I'm going to click on check because I want it to cut it. Depth of cut, like we said, is 1 mm. So the maximum step down size the cut is going to take at once is going to be 1 mm. So that's this two. We are okay with these two. So I'm going to click OK. So we can right click on this and simulate and see the operations we've done. So you can check this so that you can have your main work. You can check it. The coloration, you can use material. So now let's click on play. You can see it's taking the cut bit by bit. So we close it. After we're done with that, the next operation we're going to perform is the contouring. The contouring. This is it. So that's what we want to use to cut out the side of it. We're going to use the same tool. The end mill is still going to work for it since we're not going to take much of cuts for it from it. So our spindle speed still remain the same. Our cutting rate is still the same. So let me check the geometry. It's going to ask for the geometry. So I'll tell it this is the geometry. I can select the base. This is the geometry of the course I want to take. Uh, then this two, you don't need to tamper with it, but you can play around it so that you can see what it works for. So the next thing I'm going to check is the passes. Passes is still the same thing as the course, the cut. So you can say number of step over, the number of step over, how much the cut is going to take at once. So I'm going to tell it one won't be too much. Okay, I'm going to cheat it to one. Yeah, take 1 mm cut at a time. I don't want it to be too much. Okay, 1 mm, multiple depth of cuts. So I'm going to put it as this thing. Finished shape down is going to be around 0.2. So click OK for this two. So I can right click and simulate this two to see my cuts. So you can see it's taking the cuts bit by bit too. So okay, you can see I will have the full cut. So the next operation we want to do is to drill these 3 holes. So I'll click on drill. So now I'm not going to use the same tool for drilling. So I'll click on tool again and try to look for a tool that is compatible. Don't forget the size of our hole is 8 mm. So I'm going to click by type. So what do I need? Any drill. You can click on any drill. Okay. Now let me look for a drill that's the diameter of 8 mm. So let me move it as much as I can. Mind you, we may decide to do a rough, then we do finishing later. Anyhow, and we can take the 8 mm drill at once. You can take the 8 mm drill at once. So you can select this, select. Is somehow too long, but that is not a problem. So we set this to, we're using the same speed. But our advice we use a smaller speed for our drill. So let's put it around 300. The plunge rate. Let's reduce our plunge rate so that our drill bit is not going to cut to 22. This is to 5. To 5. So where is it that we want to do? It is O that we want to do. Now if you look at this, I only select one hole, but when I click, if I check this, select the same hole of select same diameter, it's going to look for the holes that have the same diameter as the one I selected before. So order of depth, do I want to check the order of depth? No, I don't need that. What the gain? This I don't need to work on this. The rapid in, rapid out. Yeah, table drilling. So what is it that I need? So stop boring and stop rapid out. So I'm going to work with rapid in, rapid out. So all these two deep chip breaking partial retracts. So it's going to be drilled over a time, it will be cutting, it will be retracting. So I'll click on OK. So now let me right click and let's see how this drill is going to do. Go. So you can see we've performed the drilling operation too. So now let's simulate everything. Click on simulate and let's see how everything. I'm going to use this and two parts. I don't want to see the two parts. I'm going to uncheck it. So now let's see how it's going to be. So you can see it's going to change the tool here. So it has changed the drill and voila, we're done. So after we're done with that, the next thing we're going to do is to post process. So now generate, can select one operation and try to generate the G code for it. So we are not selecting anything. Ensure nothing is selected here. So now click on post process. So for here, we're going to select the type of application we want to work with. So different CNCs, they have different applications that work with them. So you have to find the one that is compatible with your system. So for my own, I'm going to select this India ISO. So this is what I'm going to work with. And mind you, if you are selecting any software, if you are selecting a milling software and you are performing a turning operation, so you're going to get error. So for this software, I've selected it. The name of the program, let's say flat bar. So I'm done with that. I'll click OK, post. To ask for where I want to save it. Okay, mind you, I can save it. Let me save it inside the same folder. Inside the same folder, I saved other file. So can save. Okay, so it's going to bring out all the G code. Yeah, so this is the G code to perform the operations. So just save this. So just save this with the name of the ISO server. Save it. Then you export. You send the file to your CNC, and you're good to go. And if you actually want to print the code, then you click on print and you print to PDF. Print to PDF. Cam G code. So cam G code. So you can see this is, you have all the codes here. You have all the code. Thank you for watching. See you in the next video.